Hello again, YouTube. This is my third video. In the last video, I talked about basic editing of the X and Y variables, just how to move your object around. It was pretty unorganized. In this video, I'm going to talk about how to actually get some controls in your game, and also some collision detection. So, if you look to my game, you'll see that I've further improved the red ball sprite, just made it look a little bit more like an actual object rather than just a pointless red circle. And then I also added a new sprite, blue bricks, which I've also made an object for it with no code. But yeah, so let's run the game, and I'll show you what I've done since last time. So as you can see, there's this maze here, and I've got my hand on the arrow keys here. So if I just move my mouse away, I can move my character around the ball. I mean. As you can see, I can sort of just go through these bricks. There's no collisions with them yet, but as you can see, I'm moving around. I can sort of just tap the arrow keys. I can go diagonally if I hold two at a time, and actually I'll stop if I go into the edges of the screen. In the corners, you'll just stop moving completely. But yeah, so I've got some controls, and now I'll show you what I did to get those controls. So in the step event, I've completely changed the code. So up here, I've got some new stuff. You may not recognize any of this, but there is the keyboard. Oh dear. There's the keyboard check keyword or function, whichever you want to call it, and it takes one parameter, which is the key. And so what it does is you can put it in an if statement, and it will test to see if the key is down. So in this case, it checks to see if the left arrow key is pressed. The VK underscore prefix just indicates that it's not a letter or number. So these are things like the control key and the shift key and the alt key, things like that. I'll go into letters and numbers and how you actually get keyboard checks for them, probably in a later video when I actually need some. But for now, this is how you just get them. There. So basically what these are is that they check to see if the key is down. So in this case, it's checking to see if the left arrow key is down. And then I used another keyword, then, which is basically sort of skipping the curly brackets altogether. But this is, if the key is down, then x minus equals 2. Because subtracting from x makes you go left. Then only works if you have one thing that they want to do. So if I wanted it to go back and then change sprite or something like that, or change its color or do something else, I would want to use curly braces then. But then works if you're just trying to save some space and you only have one thing that you want to do. So here I've got 4 things for the 4 arrow keys, and they change your coordinates accordingly. Because they're all separate lines, 2 or more can trigger at the same time. And then over here I have the collision with the edges of the room. So last video I used just the number 512, which was the width of the room that I had set. In this I basically set it so that it's the width of the room, which is a built-in variable. So the room width variable just gets the width of the room that you're currently in. And I also use OR here. OR is something you can do, which an if statement can have more than one thing that it tests. So this if statement is checking to see if x is greater than room width is true, or if x is less than 0 is true. And if either one of these is true, then it will go here. So what this basically does is if x is greater than the room width, which is the furthest right edge of the room, or if it's less than the 0, which is the furthest left side of the room, it will go to x previous. So this basically just collides with the edges of the room. And y is the exact same thing, except it uses room height instead of room width. So room height and room width are useful if you have rooms that are different sizes. But yeah, so that's how I got the controls. And we're just going to demonstrate those again just by running them. We can see how this works. So arrow keys, just moving them around. If I hold up and right, for example, it'll make my y subtract and my x add to. It'll make my x increase. But I can just sort of move around. But there is one thing missing, which is I can just sort of go through these walls. And I mean, they're objects, but I can just sort of go through them. There's nothing stopping me. I can go to the edges, and that stops me, but just colliding with any of these objects does not really register in the game yet. So what you can do is, well, first of all, there's actually an event, which is the collision event, and you can choose another object to collide with. So I would choose collide with blue bricks, and then I would run some code under that event. What I'm going to do is I'm going to do the step event way, and there is a function called collision rectangle, which is what I'm going to do. Now, if you remember that the X and Y are in the center of the sprite, basically what collision rectangle does is you define two corners of a rectangle. So for example, I can define like up here relative to sprite, and then down here relative to sprite, and it'll make a square, sort of like that, as my mouse is showing. But what I can do is I can do x minus 8, y minus 8, and then x plus 8, y plus 8. So this is going back 8 and up 8 from the center, and then forward 8 and down 8 from the center, making two corners of a square that is 16 by 16 pixels, which is the size of my sprite. And then I'll set it to blue bricks, which is the object. And then there's precise and not me. So precise basically is whether you want to use the rectangular hitbox. That is imprecise collision detection. What you can do is, if you want it to be precise, you can set it to like that. And then if what you were colliding in was not a rectangle, if it was like a circle or a triangle, your collision would not register just by hitting its rectangular hitbox. I'll probably make a new object to demonstrate that, like right after this. But then not me is basically if you want to collide with an object that is is basically the same object as you, but it's not yourself. If that makes any sense. You can normally just set it to true or 1. You can, by the way, when I'm saying 1 for these, you can also substitute true, but this doesn't work for everything. I'm just gonna say 1 there. In any case, so what we can do is we can set x equals x previous, and then y equals y previous. And so let's test this out. So what I've done is this collision rectangle goes from the upper left corner of the sprite and makes a square that has another corner at the bottom right corner of the sprite. So when I run the game and move around a bit, anything that collides with that, when I collide in that rectangle, it will make me x previous, and it will make me go back to the previous x and back to the previous y at the same time. So as you can see, when I'm trying to run into these, I just stop. Now it isn't that smooth. If I'm going diagonally, what you might want to do is you might want to just stop you going up, and you could still move horizontally on that same wall. If that makes any sense. Like up here, I should be able to press the right and left arrow keys to move right and left, but I can't. And there are ways to do that. But this is just sort of the most simple collision detection you can possibly have, and it works for now. So yeah, that's pretty much all I wanted to go over in this video. Actually, wait, no, there are some other things. So, what you could do, I've actually been meaning to show this, but in the room settings or room tabs, there's a backgrounds tab, and there's a draw background color, as you can see, and you can set the color, and basically you can just set the room background color to whatever you want. There's another resource, backgrounds, which I haven't gone over quite yet, and I might not make a specific video for it because it's pretty simple. A background is basically a one-frame image that you can draw, and if I had one, I could set that to actually, instead of being this black color being the background, I could set a background image that I made myself to repeat or stretch across the whole screen. So yeah, that's how backgrounds work in rooms. So yeah, let's run this one more time. As you can see, I can walk through these, well, it's not really walking, I'm just sort of a sphere, but I can just sort of go through these corridors. I can run into the walls and I'll stop correctly. So that is how to do some very basic collision detection in GameMaker. If you enjoyed this video or learned something from it, feel free to like or leave a comment. I would really appreciate it at this early stage. But yeah, see you next time, YouTube.